All right, so we're going to keep talking about lines that are cut by transversal, and hopefully after time in class today, you've got a kind of a good idea of what lines cut by transversal looks like, what kind of angles they make, and what kind of relationships exist between those angles. So we're going to start with some postulates, and we need to memorize these, and not so much word for word, but we need to memorize what they tell us. And so the first one we're going to have is about corresponding angles. And it says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are. So we're talking about angle 1 and angle 3. So that is a pair of corresponding angles. If the two lines that are cut by the transversal have these little symbols, meaning that they're parallel, then we can say that the corresponding angles are congruent. Okay, it has to be parallel. If they're not parallel, you can't say the lines are congruent, and that's a very important part of our proofs. But if we do have two parallel lines cut by a transversal, then the pairs of corresponding angles are congruent. So our conclusion would be that angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, angle 5 is congruent to angle 7, and angle 6 is congruent to angle 8. Okay, our next postulate says if two parallel lines are cut by a transversal, so they all are going to start this way. Notice they all say if two parallel lines, if two parallel lines, if two parallel lines, if two parallel lines. So that's the easy part to remember. The hard part to remember is what happens over here in the conclusion side. So if two parallel lines are cut by a transversal, then the pairs of alternate interior angles, so that's angle 1 and angle 3, the alternate interior angles are congruent. And so what that means for us is that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Now don't try to memorize the numbers. That's not going to help you because that just happens to be the way the numbers are written in this picture. They could be written different in another picture, and then if you went around and memorized all these numbers, it's not going to do you any good. You have to know what position the angles are in and what their relationship is when the lines are parallel. So if two parallel lines are cut by a transversal again, then the pairs of alternate exterior angles, so that's angle 8 and angle 6. Okay, the pairs of alternate exterior angles are congruent. So we look up there, we have angle 6, it's congruent to angle 8, and we also have angle 5 is congruent to angle 7. Now our last one says if two parallel lines are cut by a transversal, then the pairs of same side interior angles are. Now let's look at the picture. Same side interior angles. Okay, what do you think the word is that goes in that blank? 3 times in a row we've had congruent, congruent, congruent. But when you look at this picture, you don't see two angles that look the same, right? If I could pull those off of there for a second, if I put them together, what does it look like they make? Hopefully you're thinking they make a linear pair. So hopefully you're thinking that those two angles must add up to 180 degrees. So the word that goes in that blank is supplementary. So our conclusion is not that anything's congruent. When we have same side interior angles and there's parallel lines, our conclusion is going to be that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. And the measure of angle 2 plus the measure of angle 3 also equals 180 degrees. Now, that might seem like a lot to remember, but what I want you to look at real quick is, erase all of this so you can see better. In all of these pictures, we either have an obtuse angle or we have an acute angle. And what you can learn here is that all the acute angles are the same. So no matter where they are, so if we had this angle 7, and we want to know, is it congruent to that angle 4? Well, we can turn it around, and we can drag it right up on there, and see that all of the acute angles have the same measurement. Okay, if that's true that all the acute angles have the same measurement, what do you think is true about all the obtuse angles? They all have the same measurement too, right? So really, you only need to remember that the acute angles are always the same and the obtuse angles are always the same. And then last, what's always true about any set of acute and obtuse angles in this type of scenario where there's two parallel lines cut by a transversal? Any acute and any obtuse are always going to be supplementary. No matter where they are in the picture, they're always supplementary. It's not too bad when you think about it that way, right? All right, so let's do a couple examples of the kind of thing we're going to have to do with these. So example 1 says, in the figures below, L is parallel to M and T is a transversal. So as soon as I know that L is parallel to M, I need to go to my picture and I need to add these little symbols that tell me those two lines are parallel, because without parallel, none of the little postulates you just learned matter. So identify each angle pair. So angle 1 and angle 5. Angle 1 and angle 5, alternate sides of the transversal, exterior of the two lines, so those are alternate exterior angles. Now, our postulate said that if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. But you can just look and see obtuse, obtuse, parallel lines, congruent. Okay, now we look at angle 2 and angle 3. So angle 2, angle 3. Okay, same side of the transversal, interior of the two lines, those are same side, interior angles. Are they congruent or supplementary? Well, our postulate says that if two parallel lines are cut by a transversal, then same side, interior angles are supplementary. But our just eye test, when we look at it, tells us if angle 2 is acute and angle 3 is obtuse, then they're going to add up to 180, no matter where they are in the picture. So remember, two parallel lines, transversal, one's acute, one's obtuse. Those are going to be supplementary every single time. All right, so let's find the measure of each angle. The measure of angle 3, that's this one right here, 115 degrees, obtuse angle. What's the measure of angle 5? Well, remember our instructions up at the top said in the figures below, L is parallel to M, right? So when that happens and we have alternate interior angles with two parallel lines cut by a transversal, those are congruent. And you can see that the you can see that the obtuse and obtuse means that they're congruent. So angle 5 is also 115 degrees. Make a little sense? So now let's look at angle 1. Measure of angle 1 right here. 130 degrees. Find the measure of angle 7. Obtuse, obtuse. Alternate exterior angles are congruent, so it's 130 degrees. Now we come down to the measure of angle 8. Measure of angle 8. Measure of angle 8 equals 47 degrees. Well, find the measure of angle 3. Okay, we have an acute and we have an obtuse. Now, those are not alternate interior because this one's on the outside. They're not alternate exterior because this one's on the inside. They're not same side because they're on alternate sides. And they're not corresponding because they're not in the same spot. So this is just an acute angle and an obtuse angle in our diagram. Well, you know that any acute angle and any obtuse angle in this type of diagram are going to add up to 180 degrees. So 180 minus 47 gives us 133 degrees. So the measure of angle 3 is 133 degrees. That's it.